Okay, so what were we adding to this? So last time we talked about how, I think we got a little farther than this and then we kind of backed up some. All right, we looked at the Python programming template. We looked at the Java programming template. We looked at compiling Java from the command line, right? And then running it. Got it. All right, so let's go into Eclipse now and look at the Eclipse version of that. So just as a reminder, do I still have Atom open here? Because our goal here is we want to kind of appreciate what Eclipse is doing for us. Remember, Java is a compiled language. So when we update our code, we save the file, we compile that file, it turns into Java bytecode, and then we use the Java virtual machine to run that Java bytecode, and that's what gives us our output. So as our example here,
I think it's like test250.
Test250.java. So if I compile it, I would compile javac. That's the Java compiler, test250.java. Assuming it doesn't scream at us, that means that we now have a class file. So if I do an ls test, let's just do test2 star. Now we see our test250 class. So that's our Java bytecode. We want to run that guy. We use the Java virtual machine, which is just called Java. And we say the name of the class, test250. And oh, that's because I think I had it where I have to put in like a command line argument. We were showing that at the end of class. All right, so that's how we run that program. All right, so those multiple steps are important for us to understand. That is part of how compiled languages work. Every compiled language requires you to compile the code, then run the code. Interpreted languages like Python have you run them directly through the interpreter. Now, modernly, for software developers, we typically use IDEs, integrated development environments, like Eclipse. All right, so we're going to use Eclipse in here. So I'll go ahead and let's see, is this the latest, greatest one? I think this is the latest, greatest one, 12 of 2020. So we'll go ahead and pop open Eclipse and we'll go through the process of creating a Java project, hello world, running it, yada, yada, yada. All right, so I'm going to go ahead, I'm going to say File, New, Java Project. And we'll call this guy CSC250 test. All right, now for where it's storing it, the default location for me is in my home directory inside something called Eclipse Workspace. I'm going to say that's fine. If you want to change that to a different place in your computer, doesn't matter, just make sure it's a place you can find. Execution environment, it already found mine. I think I showed you before to go to java.sun.com, download the Java SE. So get something that's relatively recent. It found Java SE13 on my computer. So I'll go ahead and hit finish. Now, this is where some of you had some issues. So in Java, more recently, they've introduced this thing called modules, which is kind of like a competitor to something called namespaces in like C++ as well as C#. Because we're writing relatively small applications, we're not going to actually use modules anyways. So if you want your code to work without having to do some extra stuff, just click Don't Create for the module. That way it doesn't add some extra stuff that you then have to go and delete. So when you first create your project, just say don't create next to the module. And now you have a project that once we add some code, it'll run. So what that did is it created a little folder over here on the left. And notice it embeds the Java runtime environment in here. That's the magic that allows Eclipse to go ahead and run your program directly by just hitting the play button. Okay, does it all for you. You don't need to worry about that. But again, the whole goal here is to appreciate what Eclipse is doing for you. Okay, and then you get this folder called source. And currently it's empty. This is where you're going to put your Java files. So I'm going to go ahead and right click on that source folder. I'm going to say new, and I'm going to say class. We're going to create a Java class. And very commonly, I name this top level class driver. Okay, good. You don't have the who, what? Well, I mean, did you create the new project? Okay. Oh yeah. Yeah, you'll have to have yeah, so just as a reminder, if you go to java.sun.com, I mean, your computer potentially already has Java installed on it, but if it doesn't show it in the drop down there, it doesn't. That's fine. Yeah, so you have it. Okay. I guess I'm not sure. I'd have to look at it like after class. But yeah, I mean, it should give you a folder like this. You can go ahead and try to create it again and make sure you click don't create on the module and see what happens. All right, so you got this folder called source here. I'm going to right click. I'm going to create a new class. I'm going to call this class driver because this is going to be our file that has main in it. It's going to be the file that drives our program, hence the reason I call it driver. Okay, this also correlates it to you know, something that we talk about like in the operating systems and systems programming class where you have like software drivers. You buy a new graphics card and you have to install some software. That's the driver for that software, or for that hardware rather. So what's a driver? A driver is a computer program that teaches the operating system how to use that piece of equipment in its special way over and above what the default thing that the operating system knows how to do. So it's the program that drives that hardware. All right. So I happen to just name my class, my top level class driver for that reason. All right. So I'll hit finish. I think I can make this bigger in here. Everybody can see that okay? Back row. All right. So we have our public class driver. Now, one thing you're going to want to do is you're going to want to get used to and memorize this template so you can always start Java program. So this is a public static void main string array args. So that is the template for a Java program. System.out. System.out.println hello world. All right, so that is our hello world program. So all of you should be able to very soon write a error-free hello world program. There may be a quiz some class where you have to do that. All right, so very quickly you should be able to write that default template for any Java program. Once you have this, just hit the play button and there's hello world. So what happened is it compiled it and ran it for you. So that was the equivalent of those command line things where I typed in javac driver.java and then Java driver. It did all that for you just by hitting the green play button. Make sense? Okay, but I promise that all that stuff is happening behind the scenes. It is compiling it and it is running it through the Java virtual machine. Did you figure out what was going on? Oh, it's still there. Okay. Okay. So in any case, there is your default template. Yep.
So mine still works, but at the very top in line 1, mine says package CSC250 test semicolon. I don't know why mine has that and yours doesn't.
Yeah, probably when you created your, see how mine says default package here?
Yeah.
So the
Okay. Yeah,
default
mine doesn't
package
say
is what's
that.
created by default, so that it does, you don't need to have something up there. When you created your class,
New project. Yeah.
I'm guessing you had something in here.
Okay. So don't have something in there next time.
It's not going to hurt it.
Okay.
A package is just a folder structure. We probably won't use that in here.
Okay.
So kind of that module thing I told you before is like the next level up. A module is a collection of packages. A package is a collection of classes. Go ahead.
When I tell the launch point, I said the section cannot be launched, and there are no recent launches.
Okay. That sounds like maybe you don't have your virtual machine on or whatever, but I can look at it after class if you want.
Should we have put create or don't create module?
Don't create module.
Is it worth going over like what public and what static and what void?
We're going to do all that. Yep.
Okay.
Yeah, all that's going to get covered when we get to the point where it makes sense.
Okay.
Yeah, so right now, public and static don't mean anything to us. So bottom line is this is just what you write for right now. We'll certainly give a lot of rationale to it in this class and understand exactly what those things mean. Okay, so as a starting point here, so here's our Java program template. So as a starting point, let's see, do I get into it here? All right, let's just look at, see if there's anything we need to cover from this stuff. This is some review stuff from 200. So we already talked about some of this stuff. All right, so let's go back and review our primitive types. So again, Java is a strongly typed language, which implies that when we create a variable in Java, so strongly typed deals with variables, when we define variables. And remember the three ways that, the three things that we, how human beings solve problems is we remember things, we ask questions, we use repetition. 100% of programming languages will give us facilities for those three things. So we will have a way, and the way we do memory is through variables, okay? Java requires us to say the kind of variable we will be creating. So when we create a variable in Python, we can just say name equals Mike. In Java, we'd have to say string name equals Mike. We have to define that bucket for what it's going to hold. All right, so built into a programming language, especially object-oriented modern languages, we typically have two different kinds of variables. We have primitive types, and then we have object types. So, go ahead. Do you have a question? Oh, nothing. All right, so we have primitive types and we have object types. Primitive types are built into the language. So, this is in the small font up here. Okay, it's built into the language and it's only capable of holding a value. That's all a primitive type can do. Object types can potentially hold one or more values. You don't have to hold a value in an object, but they can potentially hold more than one value. And then they can also do other things, perform like methods, functions, things like that. Now, there are a bunch of objects often built into a programming language. So for instance, and we'll look at many of them this semester, but for instance, Java has, hundreds and hundreds of classes built into the language. But a lot of times we're going to create our own classes, just like we did last semester in Python when we created like a person class and a player class and a dice class, that kind of stuff. All right, so object-oriented languages typically provide us with some predefined objects that allow us to solve kind of common problems. Like for instance, the string class is an object. Okay, so it allows us to deal with strings and do things to strings, like a string can report its length, and you can get a character at a particular place in a string, that kind of stuff. And we'll get introduced to all that stuff. But then we can create our own unique classes that are for solving the problem that we're currently looking at. All right, but let's review our primitive types that are built into all C-based languages. All right, we have multiple integer types where an integer is a whole number, positive or negative. These are signed integers. So if we look at these, we have byte, short, int, and long. So these 4 integer types are all signed integers. So byte's assigned integer, short's assigned integer, int's assigned integer, long's assigned integer. Signed means it is capable of holding both positive and negative numbers. Okay, most of you are in the 325 class this semester. So one thing you're going to talk about in there is how does a computer store both positive and negative values inside of an 8-bit memory space. If you have 8 bits to store stuff, technically 8 bits can hold the numbers 0 through 255. It can hold 256 unique values in an 8-bit number. That is 2 to the 8th power is 256. That's the number of unique values we can hold in 8 bits. Now, we can choose to have an unsigned value and not worry about holding positive and negative numbers. And then we can hold 0 to 255 inside of 8 bits. But if we want to have the ability to store positive and negative numbers, we have to have some way of encoding a number in those 8 bits so that we can keep track of what's positive and what's negative. All right. Now, you might say, well, the most obvious thing to do is maybe put a 1 in front of anything that's negative and put a 0 in front of anything that's positive, something like that, and just use the last 7 bits for the number. I'm not going to go too far into this because this is a topic you'll do in 325. But the punchline there is that will work. But the problem is we're going to say that's inefficient. Why? Because then you have a positive and a negative 0. You're not taking full advantage of those 8 bits. You're only representing 255 unique values instead of 256 unique values. All right. So what you'll learn in the 325 class is this thing called 2's complement. It's a way of encoding a binary number so that it can hold both positive and negative values. And if it starts with a 1 on the far left, it means it's a negative value, but it also means you will have to decode it to get its actual magnitude. So you know it'll be negative, and then once you decode it, then you'll get the actual value that is negative. Okay? So that allows you to have, notice here that it goes from negative 128 to positive 127. That is 256 unique values where we only have a single value for 0, and we gain an extra number on the negative side for negative 128. But we only go up to 127 on the positive. But that's 256 unique numbers. Okay? For us in here, from a programmer's perspective, we just want to think of a byte as a signed integer that could hold numbers between negative 128 and positive 127. And even not, I mean, that's something that as a computer scientist, since bytes are pretty common to us, we probably should have a good understanding of. And that's something that the 325 class will really drill into you. But I would say as a programmer, it's not necessarily important you know the exact range of values that it holds. But you should kind of know that bytes hold a relatively small value, shorts hold a little bit bigger values, ints hold even bigger values, and longs hold even bigger values. Okay? So a byte, negative 128 to positive 127, a short, negative 32,768 to positive 32,767. So that's roughly plus or minus 2 to the 15th power. Okay? Because it's a 16-bit value. So 2 to the 16th is the number of unique values. 2 to the 15th is roughly half those values, right? Well, it is half those values. And then you get an extra 1 on the negative side. So negative 32,768 to positive 32,767. You get to integers, those are 32-bit values in Java. So that's negative 2.1 billion to positive 2.1 billion, or negative 2 to the 31st power plus 1. To actually, no, that's the negative 2 to the 31st power is that's the whole number, right? Yeah. So negative 2 to the 31st power all the way up to 2 to the 31st power minus 1. That's the range. And then longs are negative 2 to the 64th power, or sorry, 63rd power, up to 2 to the 63rd power minus 1, which is a big range of numbers. All right, the number of unique values in 2 to the 64th is that 1.84 times 10 to the 19th. I think that's like, 18 quintillion or something like that. Maybe it's quadrillion. Big number, but not infinite. Not infinite. If you're doing something, physics-based or something very mathy, sciencey, something like that, it's possible you might need to operate with even bigger values, or at least you might need to make the assumption that the number of values you have might be arbitrarily large. Or maybe you want to be able to store values that go all the way up to when your computer runs out of memory, something like that. All right, so in Java, we have some objects that allow you to deal with stuff even bigger than longs. There's a class called the big integer class, and we'll look at it at some point, but that is, so then we cross the line from the primitive type over to a built-in object type that says, hey, if you really want to hold gigantic numbers with no real limit until your computer just starts running out of resources, you can flip over and use big integer, probably at the cost of some performance, because now you're not directly storing things in your computer's memory. You're kind of storing this abstraction of it. Something we'll end up writing in the 300 class is we implement kind of our own version of big integer, where we use something called linked lists, and we effectively create our own object that allows you to hold arbitrary size numbers and then do math with them. So we kind of we introduce the idea of a linked list, one of our data structures, through that lens of, hey, let's write something that we already have a framework for, but we can kind of see how that works. All right. Not something you have to memorize right now. In fact, I'll go ahead and throw this statement out here. This is related to what you asked a little bit ago, Ben, over on this Eclipse thing. Public and static, these are really, keep throwing reallys on there, important. In fact, I'm going to say one of the probably the most important, but certainly in the top 3 most important skills you need to have as a programmer is to be able to read the documentation for the code. All right, because I promise you, if I go over here, we go to, I'll just do Java SE, and I think there's an API somewhere. Let's see. Just click on all classes. All right, this is all the classes that come built into Java. I've been scrolling for a little bit, right? I'm only at the H's. A lot of classes, all right? I've been coding in Java since the language came out, okay, before most of you were things. What percentage of the Java language do you think I've even ever used? Go ahead.
Didn't you say like 1%, 2%?
Something like that, a little. So I don't have anywhere close to the whole language memorized. But what I do know how to do, and what I'm going to teach you how to do, is how to read the documentation. So that when you do need something here, like I'll just click on a random class. I've never used this one before. I'll be able to know what kind of thing. Actually, that was a module, so that was a bad example. Let's pick a different one. Here.
Event handler.
We'll pick hash map here. So this will be a good one. So I'll be able to look at this and say, oh, here's my possible constructors for this. And we all know what constructors are. We worked with those in Python when we wrote our own classes. Remember that init function? That was our constructor. So I can look at, oh, here's multiple ways I can build a hash map. Here's the list of all of the methods that are part of a hash map. This is what it returns. This is the name of the method. This is the parameters it takes. So if I'm, and then it has a little description over here. So if I happen to decide I want to use a hash map, you know, I can come up here and I can read what a hash map does, what kind of problem it solves. This is actually kind of like a dictionary in Python is what hash maps are. So I happen to have used this one before. But in any case, I can go and find the one that's good for me, the one that the method I want to use, read how it works, but then, or read what it does, and then come over here and say, this is everything I need to know about how to call this. Since this guy does not have static over here, I'm not going to go into, we're not going to drill this. I'm expecting you to know it right now, but I'll just say it out loud so you kind of have a precursor where we're going. Since I don't see the keyword static out front here, that means this guy is an instance method. And I call instance methods using an instance of the class in which it was defined. So I would need to create a variable of type hash map with its constructor, and then use that variable to call this compute if absent function, passing it a key, passing it a function, and well, those two things, a key and a function. All right, so punchline here is just by knowing those couple of things, it tells you when you go and look at some documentation that you've maybe never used before, it tells you how to call that class, how to use that class, how to use the methods in that class. Now you still have to solve the problem of, you know, being able to fish through that list of 1,000 classes that and knowing which one to call. So that's where Google searching and stuff like that comes in. But having the skill to look at documentation and being able to immediately put it to use because you understand how to read it tells you it is a very important skill. That's a skill that we'll be working with in here as well. Okay, because the goal is not to memorize a language. You'll never memorize the entire language. I suppose if you have a full-time job where you're coding in Java day in, day out, whatever, you know, there's probably going to be relatively large chunks of that language that you're going to get pretty accustomed to working with as you go through there. But it'll still be a very small percentage of the entire language. But there'll be things you won't have to go look up. Okay, and that's why I'm not a big advocate of memorization. So for instance, on exams and things like that, minus, like, you should be able to write a for loop. You should be able to create a generic class. There's some things you just need to memorize because they're kind of your starting points, right? We talked a little bit earlier about that default hello world program in Java. Memorize that. Not because it's something that, you know, is overly important that you memorize all these things about the language, but what that gives you is the ability to sit down and have a starter running program in Java. And we can even use today as an example. A couple of you pointed out you having some issues with Eclipse, right? So one thing I like to do whenever I create a project in Eclipse is I just write a quick hello world program and make sure I can hit the play button and have it run. At that point, I know I have a working project. And from that point forward, any problems I have are bugs I introduced, right? Not that I've sat here and changed 4,000 things only to find out that there was some weird thing that happened when I first started my project and it wasn't working. So make sure that you got a good setup before you start writing lots of code. All right. So here's our 4 integer types. Generally speaking, as I'm, you know, if we remember from last semester, again, I won't spend tons of time on this, but, you know, the question I asked is, why do we have 4 different ways of holding signed integers? The reality is these came from the C programming language, which was kind of an early 1970s, late 1960s type of time period. Memory used to be really expensive. I probably told the story that in 1996, I got 8 megabytes of memory for my computer and it cost $1,000. And that was after, that same amount of memory today would cost 3 cents. And that was after memory had already come down in price a bunch. This is in the 90s. So imagine how much memory would cost in 1970.
Did you download it?
Yeah.
kidding.
See, that's an inside joke. He thought when I first met him, last semester, he thought you downloaded memory. I'll never let him forget that.
I used to think that you could download RAM.
That's what he said.
Hey,
Yeah,
I asked.
you didn't get your
I
joke.
just think that you should be able to.
You should be able to.
Oh, I have a question that I've been wanting to ask one of my professors, and I haven't yet. I would like to know if you have like a solid state drive that's completely empty, right? And
Mhm.
then you fill it up with a bunch of storage, a bunch of things. Does that physically change its weight? Like on a very minute scale?
Does it change its weight?
The weight of the SSD, yeah. Like say it weighed whatever, 1 pound, and then you fill it up with a ton of memory. Would it weigh
Wrapping
like
the Christian worldview into this is kind of like how much does the soul weigh?
Yeah, that whole thing,
So, well, ultimately, this is a computer architecture question. It comes down to how does flash memory work? Because solid state drives operate with the memory is a bunch of linked flash modules, and flash modules deal with they can actually wear out from overuse. So when you store a single bit, it's not actually changing the structure of the drive. So I would say no, the weight would not change. So then you get down to the thing, well, even minutely, I mean, at some point you can even say if a little bit of dust gets on the hard drive, it might change minutely. But to your point, zeros and ones don't weigh anything because the thing that you bought to store them
has the capability for
they're
it.
not a physical thing. So I'm going to go with no, it doesn't change the weight. Final answer.
You won $1 million.
That was I would have called my grandma, asked her. I have one living grandparent still. She's super old. But she sent me a birthday card and everything, even spelled my name right. All right, so the punchline was memory used to be super, super, super expensive. So back then, when we were writing computer programs, when not only was memory expensive, but we also didn't have a whole lot of it. So now you have a very small resource that is really, really expensive. As programmers, we needed to be very careful about how we used that memory, right? Not a whole lot of it to go around. Today, memory's dirt cheap. We got a lot of it. Who cares, right? Good programmers would say, well, if I'm only going to hold the numbers between 1 and 10, I might as well use a byte. No programmer does that today. Today we use an int, and if that's not big enough, we use a long. So if you only need to hold the numbers 1 through 10, we give you a nice big swimming pool capable of holding 4 billion unique values, only to hold 10 of them. Who cares? We got the memory. All right. So we could say that's a little bit wasteful, but it's just a computer. We don't care about its feelings. And that's when the Terminator movies come in and Skynet takes over, and then we're going to wish we cared about its feelings. And if you haven't seen the Terminator movies, it's worth seeing them just for Arnold Schwarzenegger. Okay, so that's the deal with our signed integer types. So for us in here, we're probably going to use ints most of the time. Again, this is a strongly typed language, so we have to specify the kind of value a variable is built to hold. Chars are unsigned integers, okay, because these guys map to the Unicode character set, 65,536 unique values, 0 to 65,535. So somewhere out there, there's this chart called Unicode, and in older languages like C and C++, the chart was called ASCII, which was the first 256 characters in, actually the original ASCII was 128 characters, 0 to 127, but they match the first section of things on the Unicode. So Unicode is a superset of ASCII, but punchline is there's this chart out there that says a 0 is this character, a 1 is this character, a 2 is this character, so on and so forth, because computers like numbers, but sometimes as human beings, we kind of like things stored as characters because that's kind of our alphabet and things like that. We have symbols, and Unicode allows us to hold characters from a whole bunch of different languages. So the idea is that a char holds a number, and the numbers it needs to be capable of holding are the numbers 0 to 65,535, because those are the numbers that correspond to the numbers on the ASCII or on the Unicode chart. Okay, there isn't a number -7 on the chart that corresponds to a question mark. Question mark is another number on the chart, and they're all positive numbers. Now, if they had changed the chart where they had numbers -32,768 to +32,767, they would have done this as a signed 16-bit number, right? That's still 65,536 unique values. So you can bridge it from the negative to the positive, or you could just use all positive. And that's what it is for Unicode. It's a 16-bit unsigned number, which means it doesn't know how to hold negative numbers, which means it's not encoded in that 2's complement thing I told you you're going to learn about in the 325 class. Doesn't matter to us as a programmer. Bottom line for us is, hey, I create a char, and ultimately we think it holds a char. It actually holds a number, which then at runtime gets mapped into the character from the Unicode character set. All right, that's why chars are also numbers. Computers like numbers, but we'd like to have some way of getting characters into our programs. Floats and doubles are kind of like ints and longs. They hold floating point numbers though, so they have decimal values. They can hold 3.14, that kind of stuff. Booleans are our trues and falses. All right, so these are exactly the Java primitive types I have written here. If you're in C#, instead of bool, a Boolean like this, it's bool, all lowercase, just B-O-O-L. All the rest of them are the same. If you are in C++, it's capital B, capital O, capital O, capital L. And actually in C and C++, Booleans are implemented as zeros and ones, as actually integer types, probably as a byte under the hood. So you can actually do math with Booleans in C and C++, which isn't necessarily something that you would ever really want to do, but you could accidentally do that, which is why C and C++ isn't the greatest program for beginning programmers, where you just have random stuff that you try, and then you just keep trying every permutation. You wonder why it doesn't work. Now there's more permutations, since you can accidentally do math with Booleans. Same thing with chars. You can do math with chars as well. Okay, but these, what we're looking at right here, are the primitive types specifically for Java. Questions about that? All right, so let's go write some variables. Go over here to Eclipse. So remember, as I said, human beings solve problems, memory, asking questions, repetition. 100% of programming languages have facilities for those three things. So that means Java, if it's a programming language, will have a way of representing memory through variables. We'll have a way of asking questions through if statements, also switch statements, but I usually just teach if statements. And we'll have the ability to do repetition through methods and functions. So the punchline would be, and you've been exposed to these things before through Python. So the punchline is if you learn how to do those equivalent things in Java, you can already solve a whole bunch of problems in Java, right? You got the default template for a Java program. You know how to define variables. You know how to ask questions. You know how to write loops. You can do most of the stuff we did last semester with just, a couple of days of Java practice, because you learn those couple of things. All right. So variables. First of all, for comments in Java, / is a single line comment. Multi-line comment is / finished by a */. This little guy here is not required. It's just, they just do it there for looks. All right, so if you want to put something before a method or something like that describing what it's doing, you can do comments this way or this way. Okay. Variables. Syntax for a variable is type, var name, then, I mean, you can define a variable and then give it a value later if you wanted to. So the correct way of writing this would be optionally equals value with semicolon at the end. So these square brackets here is the kind of the formal way of saying optionally. Okay, so the reality is we could say int a like that. We can say int b is equal to 7 like that. And here, let's actually, we don't need these to be comments. But if I try to print out a, system.out.println a, gives me an error. If I highlight over this, notice it says the local variable a may not have been initialized. I defined a place to store a value, but I never put a value in there. If I print out b, b will work. So there's my 7. If I say that a is equal to b later on, and I print out a, now I'll get the 7 for a. Make sense? Go ahead.
How did the optional part? How did the optional part work there?
Well, I showed you right here. This is me choosing not to put the equal value thing in there. So really what I'm showing you here, and I debated not putting it like this. So I guess maybe the better way of writing this is, here's the 2 different ways you can deal with variables. You can say equals value, or you could also say type var name semicolon. This one just defines a variable, but doesn't put a value in it. This one defines a variable and immediately puts a value in it. So here's an example of me defining a variable, and then at a later point in time, I actually gave it a value. But if you don't give it a value, it'll yell at you if you try to use it. You know, if you have a coffee maker and you don't put water in it, it won't work, right? Okay, but you do have a bucket for water that came with that coffee maker. But if you don't fill it, it's gonna just sit there and scream at you. My coffee maker says fill water. Sometimes it says it even when it's full. Got a lot of miles on that guy. I actually have it sitting in, it's one of those super automatic coffee makers that like grinds the beans and pulls the shots, all that stuff. It was like, I don't know, like $3,000 15 years ago. You know, you might as well drive it into the ground, right? But you have to sit it in like a baking pan because it leaks. Not a whole lot, but you know, you get, after I have my 6th cup of coffee in the morning, I probably got a centimeter of standing water in there. I use it to humidify the rest of the house is what it is. Go ahead. That sounds like another really Eclipse issue. I mean, I can look at it after class or something, but yeah. So one thing all of you will want to do as soon as possible, let's say before next class, is screw around with Eclipse and make sure you got a Hello World program working. All right. The last thing we want is to be in week 3 when you finally come and tell me that you're like, oh, well, I haven't been able to do my homework because I don't have Eclipse working. You know, it's almost as bad as last semester when you didn't know what a virtual machine was in week 12. Not row.
Dr. Lippman.
What's up?
So I had, I typed var, and then I just put name equals Ben, and then I printed it, and it printed it, but I never like said what the variable type was. I never said string.
Oh, so you wrote this?
Yes, and
Yeah.
it worked.
So this is correct. This is a newer syntax, kind of an answer to Swift, the Swift programming language. This is still a strongly typed language. What this ultimately does is, because we put Mike in name is now locked into a string type.
Okay.
So if I say name is equal to 17 here, notice it's not happy. So
yep.
Remember we talked to when I mentioned why Swift exists? That's kind of the Apple language. It didn't exist because the Apple people were complaining about Objective-C. Apple people like Objective-C. It makes them feel special. They're already drinking the Kool-Aid. In fact, to this day, Objective-C might be my favorite language. I've been drinking the Kool-Aid for years, I guess. Swift came out. Swift uses a syntax kind of like this, which is a very comfortable syntax for people who are like coming from a JavaScript background. So the idea of Swift was let's pull people away from Android development and Java to get them over to the dark side writing stuff for iPhone. So what does Java do? They add in some syntax to try to pull them back over. So, you like the syntax over there? You don't want to put types in front of it? Yeah, no problem. We'll give that to you over here too. At some point, remember me complaining last semester about Python, how there's 4 million ways of doing the same stuff? Yeah, don't get caught up in this too much. Maybe understand that these things might exist when you look at examples online or something like that. But from a learning perspective, I'm teaching this structured idea that it's a strongly typed language. When you define a variable, you go through the mental lifting, the mental reps of deciding I'm going to hold an int, or I'm going to hold a char, or I'm going to hold a string, and you write that word before it. That will make you a better programmer, okay? And at some point, when you run into things like this won't phase you because you're like, oh, that's just, I'll call something like this syntactic sugar. They've added a little thing to the language that gives you like this foo-foo-y other way of writing something the same. I would avoid it if I were you, Ben.
So then how do we say string? Like, how do we name the variable type for string?
Just like
Okay.
that.
Okay.
I promise you we'll work with strings a lot. So that's probably, we'll get to strings next class. All right. So I would just kill this off if I were you. All right. So in any case, that's defining variables in Java. I'm going to actually go ahead just real quick and just write a couple of other things just so we have kind of like it all laid out in front of us. So ask questions. I can say if b is less than 10, system.out.println b is less than 10. Else b is not less than 10. All right, so right now b is a 7. When I go into this, it's going to say b is less than 10. If I change b to a 70, now it'll say it's not less than 10. So this is equivalent to the Python if statement where you write the Boolean expression. Remember in Python, you put the little colon at the end of it, then you had to indent stuff underneath it. All right, so notice here that this looks pretty similar. You still have that indented structure, but it's not required. Okay, loops will pretty much work the same way. Functions look very similar. So basically, any time that you would have used a colon with indentation in Python, you'll use curly braces to block in what belongs to an if statement or a function or something like that. All right, but I'll at least give this to you as a starting point. All right, homework for Monday, I'll put it up on Blackboard right after class, is we're going to write a short paper. We're going to do a 2-page paper. You can do a double-spaced, whatever, comparing and contrasting Java and Python. So we've already pretty much talked about that in class, right? But now you can go and kind of fill in any gaps of things I didn't talk about. So you really get an idea of, in the big scheme of programming, where do these two languages fall? What are they good for? What are they bad for? Things like that. But again, focus on this idea that programming is the skill set. Sound good? Questions, comments, concerns, bribes? Okay. And I did put a post up on Slack. If you want to reply to it, send me a message. I'm debating whether or not to live stream Hearthstone ladder climb on Monday. I didn't know if students would be interested in watching their professor play a video game, but I don't know. I'm pretty decent at Hearthstone. I have a world ranking and stuff, so I thought that might be a fun thing to like get on Zoom, and you guys can give me a hard time when I lose games and stuff. But you know, if it's not interesting to you, I'm not going to be offended. But if it is interesting to you, if I get enough people who'd be interested in watching, then I'll put clothes on and and stream the game, and you can see me do the ladder climb. If you're not familiar with Hearthstone, it's like Magic the Gathering. It's a collectible card game, or maybe your age group, more like Pokemon, Yu-Gi-Oh, those types things.
I heard you're a big League
Yeah,
player.
or you could do a thumbs up, thumbs down. Yeah, I just kind of want to know: will I have an audience, or am I gonna, or am I gonna have nothing? I won't be offended. All right, it's gonna really be the difference of whether I do it on my iPad or I sit at my computer and play. All right, I will see everybody on Monday.
I heard you're a big LOL player.
No, I am
He's a
not.
big everything.
What's this?
Nothing.
League of Legends.
Well, no,
Yeah.
I know what LOL is. I am not. I mean, I've played League of Legends before, but any of those games that require a lot of reflexes anymore, I was never very good at them because they came out when I was older. But I would certainly not advertise myself as